Hey, what's going on guys, and welcome back to my channel. In this video, we will be building together a microservices architecture using Spring Boot 3, which is the latest version of this awesome framework. Also, we will be using Spring Cloud such as API Gateway, Eureka or aka Discovery Service, and also I will show you how to distribute configuration using the Spring Cloud config server. Also, we will be building two microservices. I will show you how to communicate between them, and finally we will see how we can distribute all the traces to Zipkin. And all these microservices will be running on Docker. And now, with no further ado, let's get started. But just wait one second. If you're new to my channel, just go ahead, hit the subscribe button and join me to enjoy the videos that I'm publishing every week. And finally, I want to invite you to follow me on social media. You will have all the links below in the description of this video. So now, with no further ado, let's get started. First of all, let's understand what is a microservices architecture. So to answer this question, the microservices architecture is a software development approach that structures an application as a collection of loosely coupled, small and independently deployable services. Each service is designed to perform a specific function and communicates with other services through a well-defined API, and API is application programming interface or a messaging protocol. This architectural style promotes modularity, flexibility, and scalability, as each service can be developed, deployed, and maintained independently of the others. This allows for easier updates, faster release cycles, and improved fault tolerance, as a failure in one service does not necessarily affect the entire application. The microservices architecture also fosters the use of diverse technologies and programming languages for different services, depending on their specific requirements and functionalities. Next, let's dive and understand the architecture diagram of our future implementation. This is a global overview and a global architecture of our future application. So the microservices architecture is based on several components that they should be there. So first of all, here, as we can see, when we send a request from the internet or from the outside of our ecosystem, so we need to have our first entry point, which is API gateway. So this API gateway is responsible of intercepting or receiving all the requests and then redirecting them to the correct service. And then inside we will have two microservices. One microservice is for students and another one is for school. So this means like a student studies in a school, and a school has many students, so it's gonna be a small business application. But this is not our focus, but because we need to understand first what is microservices architecture, and each microservice will be communicating with a database running on Docker. And then by the end of this video, I will show you how you can implement distributed tracing, means to trace all the requests of your application to Zipkin. Then when we talk about microservices, we mainly talk about discovery server and also config server or configuration server. So here let's understand globally this diagram. So we mentioned that we have an API gateway, which is our entry point or the gateway for all the incoming requests and outgoing requests for our ecosystem. And then we see right here that we have a config server and a Eureka or a discovery server. So each microservice in here, when it starts, it needs to register itself into the discovery server. So this discovery server will be also used by the API gateway to determine what are the running services. And also to have a better control on the configuration and have a distributed configuration, we can create, and we will create, of course, this config server where we will externalize all the configurations of our applications, including the Eureka server, each microservice, and the API gateway. So as you can see here, all the microservices that we have here, they will pull the configuration from this config server, including the Eureka and also the API gateway. And when each application starts, it should register itself in the discovery or our registry server. So this is overall our future architecture or the future application that we will implement. And first of all, let's start by creating or preparing our workspace, and then we will be creating each of these microservices, and then we will implement each microservice, or like the business logic or the business services that we have here, student and school. After that, we will ensure, and I will show you how to communicate two microservices together. And finally, I will show you how to add these distributed tracings. And I will show you how to add Zipkin and how to run it, and also how to log and trace all the logs to this tracing application. So to bootstrap our application, first of all, I created an empty project in my working space and I called it Microservices, and then using IntelliJ, I just clicked on File and then Open, and I selected the folder where I want to have my workspace and just opened it. Because in this project and in this video, we will be using a monorepo approach. This means that we will have all the code in one place. It's not a modular application, but it's just monorepo, having everything and all the code in one place. What I did also is I just created a readme.md file containing this title, Microservices Sample Project, and it's by Alibou. And here you can also find the URL for my website where you can find so many useful courses about Spring Boot, Spring Data JPA, also how you can integrate PayPal payments, and so on and so forth. So I really invite you to have a look there, and also you can get certified from my platform. Now let's create the different projects and the different microservices that we need for this architecture. So as you can see here, we will start by creating an API gateway project, and then the discovery server, and then the config server project. So we will have the tools or the side microservices ready, and then we will create the business microservices. And finally, I will show you how to integrate Zipkin. So let's go ahead and do it. First of all, let's start with our API gateway. So it's going to be, of course, the project, it will be Maven and Java language. And at this time, it's 3.0.5 for the Spring Boot version. And for the group ID, it's going to be com.alibou. And here I will call it gateway or API gateway. So this is the gateway, and we can leave the rest as it is. And here for the dependencies, let's select gateway. And also we need the Eureka client, the Eureka discovery client, because as I mentioned before, the API gateway also needs to read the configuration from our discovery client. And since our API gateway also will read the data from the config server, so we need to import also the config client, and all of them are from Spring Cloud. All right. And finally, we need to add the Spring Actuator, this one. So this is for operations and also to expose metrics of our applications. We will see that later on. All right, so now we have our gateway ready. So let's generate it, and then let's just move it to our workspace, and I will show you how you can import this within IntelliJ. So in my workspace here, I will just paste the generated zip file and I will extract it in here. So then I can remove this one. So I have my gateway application. Now I will open my IntelliJ, and here we see that the gateway is now in the workspace, but I cannot run this application. So for example, if I go right here, I see that even the SDK is not set up. So I can click first on setup SDK, and you can use the one already installed, but it's not yet imported. So what to do is you go to File and then New, and after that module from existing source, and then open your workspace and just select the pom.xml file and just click on open. And you will see first of all that you will have this Maven icon popping up, and now even the icon and the display of this project is changing. So now we have our monorepo project, and inside this monorepo we have the gateway. So for the next services that we will be creating, it will be exactly the same way. So every time you need to go File and then New, and then module from existing source, and you just need to select your pom.xml file or Gradle if you are using Gradle, and then just click on import, and you will have your application imported in here. Now let's create the second microservice, which is the discovery server. So let's call it again com.alibou, and of course Maven and the latest stable version of Spring Boot. And here I will call it discovery, and I will keep the rest as it is. And now I need to search for Eureka. And for Eureka, we have discovery client and we have the discovery server. So we want to create a server right now. So this is the microservice responsible for the server, or that will be our discovery server. So just create or select the Eureka server. And then, since also Eureka will be reading from the config server, we need to import our config client dependencies, which is Spring Cloud config. After that, we will need our actuator. Of course, we need it for the metrics, and that's it. So now just click on generate and import the service in your IntelliJ. Now let's create our config server. Again, it's Maven project, and here I will use com.alibou, and then I will call it config-server as an artifact. And here I will just rename the package to make it config server as one word. And here simply I need one annotation, which is config server, which is this one right here. Be careful between choosing the config client and the config server. Now we are creating our config server, so we need this one. And then click on generate, and of course import your project in IntelliJ. So after creating the three basic microservices that we have here, config server, discovery, and gateway, now we created one part of our application. And as we can see here, we have our API gateway, our discovery server, and also our config server. So the next steps will be creating these business microservices. But before that, let's configure our discovery server. And also the config server we will create it, and we will be implementing this config server by the end of this course. So stick to the end, and you will see how we can configure and externalize all the configurations. But now let's go ahead and implement this Eureka or discovery server. Now within my IntelliJ, I will go to main and then resources, and then have application properties. So first of all, I will just rename this and use YAML representation. I will make it full screen, and now I will add some properties. So first of all, since it's a discovery server, I will add eureka.client. So first of all, I will create eureka.instance.hostname. So this will be the host name of our discovery server. So it's localhost. And then I have eureka.client.register with Eureka. So by default, this is true, and I need to turn it to false because Eureka does not need to register itself with itself. This is what it means. And then we have fetch registry. Also, we will set it to false because we don't need to fetch the registry. And then we have the service URL, and our service URL, we have our default zone, and then the default zone is going to be HTTP // and then I will dynamically inject my Eureka instance host name. So this one, so this will refer to this one. So in case I have a different environment, so it will automatically read from this one. And then I will need, of course, the port. So it will be server.port and then /Eureka/. So this is the first configuration, or the configuration of my Eureka server. Then I need to specify my server.port. So for this one, I will be using 8761 as a port. And then since we have our config server, now I want to tell the Eureka to read the configuration from my config server. And to do that, it will be spring.config.import. And here to import, we have several options, and I will be using this optional. Optional means if this application or if this microservice doesn't find the configuration on the config server, it will not fail to start up. And then it will be config server and colon, and then the location. So it's gonna be HTTP:// and localhost, since my my config server will be running locally, and then I will give it this port. So I will also, when I create or when we configure our config server, we will give it this port 8888. And then after adding these properties, we will go back to our discovery application.java, and here we need one annotation, which is enable Eureka server. So this will enable or will activate the auto configuration of our Eureka server. Now let me show you when you correctly configure and implement your discovery server, how it looks like. So here I will go to services, or you can just run it from here. But for me, I want to run everything from one place. So here I see in this view right here, services. Otherwise, if you don't have it, you can go to view, tool window, and then you have the list of the services that you can display. And then I will select my discovery application and I will run it. So the application is up and running. Now, if I go to the browser and go to localhost and then 8761, so you see right here that we have, this is the Spring Eureka. And then we see that currently we have no instance available. So then when we will create our business microservices and start them, they will be automatically registering themselves in here, and we will see the list of these microservices. Now let's create our student service. So here I will just create a new project. It will be Maven project, the same Spring Boot version. And here I will use com.alibou. And then I will use student for this one. And also the package, it will be com.alibou.student. And then I will just add some dependencies. So for the application, we will need, first of all, PostgreSQL. It will be our database. And then I will use Lombok, and we have Spring Data JPA. So all this you already know. Otherwise, you can just go and check my website for more insights about this. And of course, since we are building a REST API, we need Spring Web. And now let's come to the cloud dependencies. So first of all, we need our config client to read the configuration from our config server. And then we need the discovery client. And finally, we will need our Spring Boot actuator. So then click on generate and import the project in your IntelliJ. So now let's start configuring our student project. So first of all, let's go and add some configuration. And here, the first thing, I will use the YAML representation as you know, my styling. And then let's add the configuration. So first of all, let's add the Eureka configuration. So it will be eureka.instance.host. And it will be localhost, since our discovery server is running or will be running on locally. And then we have client, and of course we have the service URL and the default zone. So the default zone, it will be http://localhost, and then 8761, which is our Eureka port, and then /Eureka. So this is the configuration for our discovery client. And then I will just move to the bottom, and I will add a port. So I will be running this application on the port 8990. And then let's add some Spring properties. So the first one, it's gonna be spring.application.name. So I will give a name to this application. So I will call it students. And this is the name that will show up on the discovery or the Eureka interface. I will show it to you later on. So then I will add the config, the location for the config. So it will be spring config.import. And then we have optional, and then our config server, and then colon, and then HTTP ://localhost, and then we have the port, which is 4x8. Now I will also configure my data source. So I have here data source, and then driver class name. So it will be PostgreSQL, and this is the normal configuration or the classic configuration that we know. And then we have, of course, the URL, and then it's JDBC :PostgreSQL ://localhost, and then the port 5432, and then slash students. I will call my database students. And then of course we need the username, which is username for my case. And sorry, it's not Hikari, but just username and password. So it's username and password. So then we will add some JPA properties. So jpa.hibernate.ddl auto, I will just say create, and then database, it's PostgreSQL, and I will add also the database platform, which is org.hibernate.dialect.postgresql dialect. So this is the configuration of my application. Now, if I run it, I'm expecting this student service, the new microservice, to be registered on my Eureka discovery service. So let's go ahead and do it. Now I will open services and I will run this one because I need it running. Let's enable the Lombok processing, and then I will be running my student service. So now if I go back to my browser and refresh this page, so we see here that we have the students application because we gave it the name students, and then the status it's up, and also we see that it's running on this port or this location. So this is the port that we chose, which is 8090. So now we have our student application up and running. Now we can move on and implement the logic or the small logic for our student microservice. When implementing a monolith application, so we will have a class diagram looking like this. So we will have our student entity and also our school entity, and then they will be related one to many because one school has many students and a student only studies in one school. So when we create our relationship and on the database side, we will have a student with a foreign key, the ID of the school, and that will be our class diagram. But now, since we are in a microservices architecture, we need to handle this one. So let me show you how we can do this. So within our student microservice or project, now I will create an entity and I will call it students, and it will has the following annotations. So first of all, it will be entity, and then I will need the getters and setters from Lombok. Let me make this full screen, and then setters, and also all args constructor and the no args constructor, and also I might need the builder. So now for the student, first of all, I will create a private integer ID and I will give it the ID annotation. So if you want to know more and to learn more about the Spring Data JPA, you can go and check the new course that I recently created, which is the Spring Data JPA Masterclass. And this masterclass, it's more than 5 hours of Spring Data JPA, and you will learn everything about Spring Data JPA, including inheritance, how you can create the relationships, Hibernate versus JPA. Also, you will have a better understanding of the Hibernate entity lifecycle, how the repository works, and so forth. It's more than 5 hours of video content. So if you're interested, just go ahead and check it. Now let's go back and finish our student class. Also, I will have a private string first name, and I will also have a last name. And let's say we can also add private string email to our student class. And now, since we have a relation between the student and the school, and since the student is a whole domain and the whole application, it will be only referenced by a private integer school ID. And then when we work in microservices, we need to ensure the data integrity manually. All right, so now we have our student entity. Let's go ahead and create the repository. Now let's create a new class, and it will be an interface. Let's call it student repository. And this interface will be extending the JPA repository. And then it will be of type student. And also our ID is of type integer. So this is all we need to have a repository working. After that, let's create our student service. So I will create a new class. I will call it student service. And of course, this one, we need to add the service annotation, and we need the required args annotation from Lombok. And first of all, I need to inject my repository. So student repository, and then I call it repository. And in this application, it will not be really business huge application, but we will have just two endpoints, one for saving a student and the other one for finding all students. And also I can give you the freedom and the time if you want to implement more and more endpoints. So let's create the first one. It will be a void save student, and then we need student as an input. Also, as I mentioned, you need to follow the DTO pattern, and you need to create a different object. But here, just because we don't want to make this part so long, I'm just using the entity to create and to expose all the information. So now all I need to do is repository.save student. And the second method, it will be a public list of students, and I will call it find all students. And simply I will return repository.findAll. So now we have our two methods. Let's now go and create our controller. Now let's create our student controller, and I will create a new class, student controller, and then I will need the REST controller annotation and of course request mapping, and it will be /API/v1/students. And I will create, of course, I will need the required args constructor from Lombok, and I will inject my student service. I will call it service. And first of all, I will have a post mapping, and then I will have a response status. And for this one, I will just return accepted or created. And then it will be a public void save, for example, or save student. And then we will have a request body, which is an object of type student. And all I need to do is calling my service.save student, and I pass the student as a parameter. And then I will create a get mapping, and this is gonna be the find all method. So it will be public response entity of type list of students, and then find all. So here it will be just returning response entity.ok and then service.find all students. And that's it. Now we have our student API ready to use. We can whether go ahead and test it, or let's move on and create the school service and use it. So here, just one thing, don't forget to add the final keyword. Otherwise, it will not be automatically injected or added to the constructor. Now to create our school microservice, I will keep the same interface like here, like we did for the student, with the same dependencies. And I will just change this one to school. And here we will have our project ready to download. Let's generate it and open it with our IntelliJ. Now I have my school project ready to use. And in order to make it easy for you, all I will need to do is to copy everything from the student. So first of all, I will copy the properties, Control A, and then I will paste it in this school. So here I will open main and then resources, and then this application properties, I will just use YAML, and then I will paste just here. So now I will just change the port from 8090 to 8070, and then I will be using the same configuration, except here it will be schools as database, and the rest I will keep it as it is. Also, don't forget to change the application name. So let's call it schools, and the rest nothing to change. Now let's just copy the implementation. So I will expand this one, and I will copy student and service and controller. So Control C, and then let's paste this one and rename what needs to be renamed. Paste it in here. So now instead of this student, we will call it school, and then it will ask us if we want to rename the parameters. Of course we want. So let's just do refactor, and then for the information of the school, we need the ID. This one, it will be name. we can keep the email, and we don't have any other school ID. So the school is just a simple one. It's an ID, name, and email. Also, let's rename this one from student repository to school repository. And we see already that the school was already renamed. And then let's rename this service. So let's call it school service. And we see here that we are using school repository. This one, I will just rename it to save school. And here I will call this one find all schools. Then we need also to rename the controller. So I will make this one full screen, click on the name, and then just rename it to school controller. And here, instead of students, it will be schools. All right, so we have almost everything. So here we have save, and let's rename this one to find all schools, and everything is ready now. So now let's just start the application and see what will this microservices, what they will give. So now let's start the different microservices that we have and see what are the changes. So first of all, we will need our discovery application. So let's run it, and then we will need the school and the student. So I will be running these three microservices, and as you can see here, the discovery application is running on the port 8761, school application is 8070, and the student application is 8090. Now let's go and open our browser and see what are the changes on the Eureka config server. So now if I refresh this page, I see that I have two running microservices. The first one is schools and the second one is student. Now, since we have these two services up and running, and they can be running even outside of the microservices ecosystem, this means that we also, from our local application or our local machine, we can directly access the student, and we can also directly access this school microservice, even if both of them are inside our microservice architecture. But the way to protect this is to have all these applications right here running in a private network, and we only expose to the public only the API gateway, which is our only entry point. So this is how you can fix this one. But since it's running only locally and it's only on our local machine, so it's also possible and it's also okay to be running and using these microservices from the inside. Now let's go and try this. So within Postman, I prepared the endpoint. So I prepared the first endpoint, which is save student. The first one is, so within Postman, I prepared all the necessary queries, and the first one is to save a new school, and I have another one is to create a student, and then I have another one is to get, for example, the list of schools or the list of the students. So now let's go ahead and try the creation of a new school. So I will click on send, and we see that we have 201 created. For example, I will create a school 2 and then a school 3. So here I will just create 3 schools, and now I can go back to my database and make sure that I have 3 schools created. So here within our database, we can go to schools, refresh this one, we have our table, and now we see that we have these 3 schools and these 3 random emails. Let's go back and also check the students. So this is our student table, which is empty for now. Now let's go and insert some students. In here, using this endpoint, I have a random first name, random last name, and a random email, and I will be inserting some students for the school with the ID number 1. So let's insert them. Let's insert, and also let's insert some students for the school number 2, and some of them also for the school number 3. Now, if I go back and check my database, and I will refresh here, I see that I have all the students that I just inserted. All right, so now we have Okay, so now we have this microservice running. This one is running, and also both of them are registering themselves to the discovery server. Now let me show you how we can ensure communication between the student and the school, and we will be creating a new endpoint. We will call it school with students. This means when I try to get a school, I want to get the school and all the students that are in this school. So let's go ahead and implement this. So now let's go back to our school microservice, and then within the school controller, I will create a new endpoint, and it will be a get mapping. Also, I can just duplicate this one, and it will be, as I mentioned, it will be a get mapping, and I will call this endpoint with students, for example. And then slash, I need to pass the school ID as a path variable. So this one is going to be school ID, and here it will be a path variable, and then school ID, and here it will be integer school ID. So then instead of find all schools, I can do find schools with students. So find schools with students, and then I need, of course, to pass the school ID. So now I need to generate this method. So let's go to the service and create this find school with students. So I will just use the auto completion from IntelliJ to generate this method. And this one, it will be a list of, and here instead of a list, I will just return a new object, and I will call it a full school response. So here I will say full school response. And this will be, or this object will be the return type. So let's go back to our controller, and instead of a list of school, and it will be just a response entity of full school response. So this full school response, it's a new object that I don't have right now. Let's go ahead and create it. So I will create a class new school or a full school response in the same package, and then I will just paste it. And this full school response, it will hold the same information as we have in this school.java. So it will be the name and the email. And then we need a list of students. Let's call it students. And for now, we don't have yet this student object. So I will just open this student.java class, and I will just copy these three information right here. And then let's create a student object. So here, let's create a class student within the same package. So here, let me show you how this looks like. So here we have this full school response, and we also have this student object. So within this student, I will paste these three attributes, and I will add some Lombok annotations. So it will be getter, setter, and then all args constructor, and also no args constructor, and the annotation builder in case we need it. So I will just copy these annotations and also paste them here. So now I need to import this list, and now we have our full school response representation. When we ask for it, or when we invoke this endpoint, we will be returning the school information within all the students that are in the same school. So now let's go back to our school service right here. So what we need to implement, first of all, we need our school equals our repository dot find by ID, and then it will be a school ID. And what we can do or else. For example, we can just return a new school object. So for example, let's say school .builder.build. So this just to avoid null pointer exceptions or like unhandled exceptions. So let's say it's gonna be something like this .name. So it will be not name, let's say just not found, for example, and then .email, and also we can call it not found. This is just to return something which is readable. And then what we need to do here, we need students equals, and here let's say null for the moment, And now what we need to do is to find all the students from the student service or microservice. So this is what we need to implement right now. So let me show you how we can communicate or how we can implement a communication between two microservices. But first of all, we need to go to the student microservice and prepare this method that we need to consume. Now within our student controller right here, let's create this new endpoint. So I will just copy this get method and I will call it or give it the URL /school. This means I want all the students /school, and then I need to pass the school ID as a path variable. So here it will be also a list of students, and now we need our path variable and then school -id and then integer school ID. So here it will be find all students by school, and then we need to pass our school ID. So now let's go to the service and create this method, and it will be a list of students. So it will be repository dot find all by school ID and then school ID. So since we don't have yet this method, and now let's just generate it. So if you want also to deep understand how these methods works and how these queries are generated in the background, I invite you again to have a look on the new course that I just released, which is the Spring Data JPA Masterclass. Alright, so now we have our new endpoint that will allow us to fetch all the students by a school ID. Now let's go back and finish the implementation of the communication between these two microservices. Before starting the implementation of establishing the communication between the two microservices, there is one dependency that we need to add. And to do that, let's go back to our Spring initializer, and in here just add a new dependency and search for OpenFane. So this OpenFane is a declarative REST client. OpenFane creates a dynamic implementation of an interface decorated with JAX arrays or Spring MVC annotation. So let's just add this, and here let's go explore and let's search for this OpenFane, and then we can copy and paste it in our project. So now let's open this pom.xml from the school project, and now let's paste this, and then don't forget to refresh the Maven project in order to download the new dependency. So now we have the required dependency. Let's start implementing. The first thing we need to do after adding the dependency, let's go to our package right here and create a new Java class, and then select interface, and let's call it student client, and let's move it to a package and call it client. So it will be client.studentClient, and here the first thing that we need to do is Fane client annotation, and this Fane client annotation, it will be responsible of establishing a communication and making an HTTP call to our distant API or our third-party API. So here let's give it a name or a value, and here let's call it student service, and then we have the URL information, and for this URL I will just externalize this one, and I will move it to application.config. Let's call it students URL. So I don't have this one yet. I will just copy it, and now I will go to my application YAML and scroll to the bottom, and here it will be http:// and then localhost and then 8090, which is the port for the student's URL, and then /API/v1/students. So this is the URL of our student endpoint or student microservice. Now let's go back here. So what we need to implement is a get request. So it will be a get mapping right here, and then it will be /school. So this is the endpoint that we have in here. Let me just remind you. So if we go back to student controller, it's /school/school ID. Let's copy this, and I will just paste paste it to avoid typos. And now it will be just a public, or we don't need public with interfaces, so it will be a list of students. So the student here, just make sure and be careful that it's from the alibou.school, which is the school project. Now let's import also this list. And then let's say find all students by school. And here we have our path variable, which is our school ID. And then we need the integer school ID. And that's it. So this interface and this method right here will be, or will have an automatic implementation provided by Feign or OpenFeign, and it will establish a communication with our student microservice. So now let's go back to our student or school service in here. So instead of this null, first let's go and inject our student client. Let's call it just client. And then the student, it will be client dot find all students by school ID or by school. So now we have, let's just rename this one. So find all students by school, and we pass the school ID. So now we simply need to return this full school response.builder.build. And now we will have the name, which is the school.getName. And then we have the email, which is also the school.getEmail. And finally, we have our students, which is the students that we just fetched. Now let's start the application, and we can try and test this one and see and make sure that we are making a communication between these two microservices. So again, let's restart these three applications. So all of them are up and running. Let's check on the discovery of the Eureka user interface. And here we see that we have these two microservices up and running. Let's go to our Postman, and then I will insert some a new school. So school 3, and also I have school 2 and school 1, for example. And I will insert just a few students for the school number 1. So we have always 201. And now I will just use this one. So it's schools with student. And for this one, it's just, I will be using the normal port, which is this one. So now if I do send, so now we are getting a 500 internal server or error. So let's go and check this. So here, just click on the application that you want to see the logs from. So it's school application, and let me make it a bit wider. So here we see that we have a null pointer exception, which is cannot invoke this student client, find all student, and so on and so forth, because the client is null. Even we injected this bean, but we are missing something. So let's go to our school application. And here within the school application file, we need to enable Feign clients. So if you don't add this annotation, you will not be able to run or to execute any of the Feign clients. Now all we need to do is just to restart the school application, and let's go back to our Postman. So again, I need to insert at least one school. And now if I click on send, we see that we have this school, and we see all the students from the school. So let's try to insert some other schools. Let's say school Alibou. For example, I will insert this one, and I will go back to the database and check the ID. So if I open this and I open the schools, and this one has the ID number 2. So let's go back and insert some students for this school. So here, ID number 2, and I will click send a few times. And now if I try to get all the students from this school, we see that it's school Alibou, and we see the list of students. So we established a communication between these two microservices, and we were able to communicate the school with the students. So when we fetch a school with all the students list, so we are able to establish this communication. Now let's move on and made some changes, and now let's make our two microservices available via this API gateway, because for now we are accessing these two microservices directly using their endpoints. Now let's access them using the API gateway. So now in order to have our API gateway up and running, we need to add some properties. So let's go to the resources, and here instead of properties I will always use YAML, just as you know it. And now I will make this one full screen. So first of all, I will add the server.port. So I want to run this application on the port 83x2. And now let's add some configuration. So first of all, it will be Eureka.client and then register with Eureka. I will set it to false because I don't want to register this microservice or the API gateway with Eureka. Otherwise, if you need it for some reason, you can also remove this property right here. Now let's add some Spring configuration. So we have spring.cloud.gateway, and then we have the discovery locator enabled. So by default it's false, and I want to set it to true. So I want to fetch the information or the data from the discovery server. And then within the same level as discovery, let's add some routes. So for the routes, it's a list of routes. So it will be, first of all, we need to give an ID to each route. So the first one, it will be students. And then we have a URI. So the URI is HTTP, so where the API gateway should redirect the call. So it's localhost and then 8090 for the students. And then we have a list of predicates. So the predicates is when the path contains the following. So when the path contains /API/v1/students/anything, I want to redirect this to this request to the students endpoint. Now I will just duplicate this one, and here we have schools, and then instead of 9080 it's going to be 8070, and then we have this predicate. So instead of students it will be, and then let's add the application name. Let's call it gateway. I'll just move it to the top to have this alphabetic order, and don't forget to add the config dot import and then optional from our config server, and then it's located in the http:// localhost and then 4x8. All right, so now we have our API gateway up and ready. So all we need to do is to run this gateway and try to invoke all the endpoints that we did before from this API gateway. Now let's run all the services and test them. So we need, first of all, the discovery, the school, and the student. So let's run all of them at the same time. And we also have this not started, and we need to start also the API gateway. So the API gateway is also up and running. So if we open again our Postman, and now if we go back to this endpoint, for example, to create a school, we know that the school is running on this port. But if I change it to 83x2 and click send, I'm expecting also a 201. So this is what we see, and we can also let's create school 2 and maybe a school 3, and also let's do the same with the other endpoints, and then we can go and check that everything or all the requests are passing through the API gateway. So let's click on send, and here I will also assign them to the school number 1. And so I'm sending few of them. And now within this endpoint, instead of this port, I will use the 83x2. So, and I click on send, and we see that we have this response. Also, if I change it, we also see that we have a response. So now what we can do as a next step is also, when we want to communicate these two microservices, in here, we can, when the school needs to fetch the students, we can send the request to the API gateway, and then the API gateway will redirect this request to the student, and then it will go back. So otherwise, we can even make an internal communication, since these two microservices are within the same private network. All right, so in order to do that, it's quite easy. So if you want to do it, let me show it to how you can do it. So now let's go to our school project, and then let's open the properties. And here, instead of this port, all we need to do is to use this one. Now, if I restart the school and test again, you will see that everything will be working fine. So now I want to show you the next step is externalizing all this configuration that we see here. I want it to be external. I want to have all this configuration in this config server. So I don't want to have any local configuration. And why I need that? Because the config server will ensure that every time we need to change some configuration, we just change it in one place, first of all, and then all the changes will be propagated to all the microservices. In order to ensure the distributed configuration for our application, first of all, we need to configure our config server. So first, let's go to the resources and let's use YAML representation in here. And now let's add some properties. So first of all, as we mentioned before in the previous configurations, so we want to use the port 4x8, and then let's add some Spring configuration. So here I have Spring, and then profiles, and then active. So I want to set the active profile to native. This means that it will be or automatically use the native active profile. And then let's also give a name for our application. Let's call it config server. And then within Spring Cloud, and then config, and then server, and then native, and finally search location. So the search locations means where Spring config server is going to fetch all the configurations that we want, and it will be class path and then :/configs or configuration. So these configurations, I will just copy the name right here, and I will create under resources. I will create a new folder and I will call it configurations. So Spring config server will automatically start fetching the configurations from this location right here. So now the next step is to enable the config server. So open the config server application and here add the annotation enable config server. So now we have our config server up and correctly configured. All we need to do as a next step is to add the configurations for each microservice. So let me show you how to do that. So now let's externalize the configuration for our school. And then first of all, I will be just copy pasting these properties. So I will just Ctrl A, Ctrl C. I will just copy this. And then I will go back here. And under these configurations, I will create a new file, call it schools.yaml. And here, make sure that this file name is exactly the same file name which is this one. So let's paste everything. And now all we need to do is to clean up a little bit so we don't have this config import and so on and so forth, because it's already in the config server, and we can keep the rest as it is. So now all we need to do just to make sure that everything is working is restarting the application, but we will do it once we externalize all the configurations. Now from this application YAML in the schools, all we need to do is just to remove everything, and all we need to leave is this application name and config import, and the rest we can just remove it. So now, as you can see, we have a really clean and few lines of code in our application.yaml file for the school project. So let's do the same for the other project, which is the gateway. We can also do it for the discovery, and we will do it for the students. So let's do it one by one. Let's now do the same for students. So I will just go here and just extract all this. And then in the same place, I will create a new file and I will call it students.yaml. So if, for example, if you choose to call your services school service or student service, just make sure you give it the same name here. And now let's just remove this one and keep the rest. All right, let's go back to our student and let's clean it up. So the port we don't need, everything we don't need except the application name and the config, and we can just remove the rest. And now we have again one clean config file for our microservice. Now let's externalize the gateway. And again, the same way, let's open our application. And here we just gave it the name gateway within the config server source and then main and then resources and configuration. Let's create first of all our file and give it the name gateway.yaml. And now let's copy all this configuration. And now we need to remove this config and the rest we keep it as it is. So now let's also clean the original one. So we don't need this, and the rest also we can clean up. So again, we have our final application YAML for this gateway. We still need only to migrate or externalize the discovery properties. So from the discovery here, we just need to give our application name and let's call it discovery. And then let's create a configuration file for it, discovery.yaml, and let's externalize all this configuration. So here, and then all we need to do is just to remove this. And now let's go back and clean up all this. We can just remove this one and leave only this. All right, so we externalized everything. Now let's start the application and make sure that this configuration is correctly read from the config server and that the application is still up and running. So now, first of all, we need to run our config server since we will be reading all the configuration from there. So it's the first service that we need to start. And now we are up and running with this config server. And now we can just start the rest at the same time. So I will just select all of them and click on run, and it will be running. And if everything is up and running, we will see all the applications starting on the correct ports and so on and so forth. And now to make sure that everything and all this configuration was correct, now we can just go and try to insert some data and play with our microservices architecture. So in here, I will just insert again a school. So click insert and we see that we have 201, send again. And also I can send or insert some students. And then you can see that we can fetch, or I can fetch all the information from our backend. All right, so now at this level, we implemented all the parts of our application. So we have our API gateway, the different microservices, they are correctly communicating with each other. And we also have our Eureka and config server. So now all we need to do finally is this distributed logging. So we need to add and install Zipkin, and then we need to redirect all the logs and the tracings from our application to Zipkin. So first of all, as I mentioned, we need to install Zipkin. So let me show you how to do that. So to help you and make your life easier, so I just created a Docker Compose file for you containing all the services that we will need to run this application. So first of all, we have this PostgreSQL. So this is the database container that we are using. And here you have all the configuration needed. Also, if you don't have the ultimate version of IntelliJ and you don't have this menu right here, you can just access your database using this Postgres admin available on this port right here. So then we have the service for our Zipkin. So it's just a container. Also, you can find the official image and how you can just simply run it, or even if you want to install it on-prem directly on your laptop, you can just go to the Docker Hub to find the information for that, or to the official website and just run it. So this Zipkin service, we gave it a container name Zipkin, and then it's from this image. So this one is the image that you can find on the Docker Hub, and then it will be running on the port 9411. And then we have a list of networks, which is this configuration right here. So I will not go so much into the details of this Docker Compose file. You can just find it in the source code, and then you can just copy it. Okay, so once you copy and once you have this Docker Compose file, so you can just click on services and run all of them. Or for example, if you have PostgreSQL already installed and you have everything you need except for Zipkin, you can just click and run only Zipkin. And then you can access the Zipkin interface on the following URL. So all you need to do is just go to localhost and then the port 9411, and then you will see the Zipkin interface. So for the moment we have nothing, we don't have any logs because we did not implement logs yet. So let me show you how we can add or how we can distribute the logs to Zipkin. So the first step we need to do is to add the Zipkin dependencies. So here let's search for Zipkin and then click on explore, and you will see that when you add Zipkin, you will have two different dependencies, not annotations, but we will have two different dependencies. The first one is the bridge Brave and the second one is the reporter Brave. So let's just copy them and add them to all our microservices. So now, first of all, within our API gateway, let's add this dependency. Just go to the bottom and paste it. And of course, don't forget to reload the project. Also, we can add it to the school and then student. Now we have Zipkin already available. And since it's a starter, it has an auto configuration. And all we need to do is just to run the application, and then we will have all the tracings going and distributed to Zipkin. But to ensure that we get everything, what we need to do is just to add some management configuration to tell that the probability of distributing all the logs and the tracings to Zipkin, I want it to be 100%. So let me show you how to add that. So now let's go to our config server and then to main, resources, and then configuration. And for the gateway, school, and students, let's add this configuration. So I want to add management and then tracing and then sampling. And let's add the probability, and let's make this probability equals to 1.0. So I will just copy this one and paste it also in here for the school and also for the gateway, since the gateway also will have some tracings. And now let's run our application and let me show you how all the tracings and all the logs will be going directly to Zipkin. All right, now let's first of all run our config server, and then we can run the rest of the applications. So let's run them one by one. And now let's go and make any request. So let's open our Postman and let's, for example, create a school. So here it's 201. Now let's go to Zipkin and I will just run query. And as you can see right here, I have the first log a few seconds ago. And if I click on show, we see that here we have a post and it went through the API gateway, and from the API gateway, it went to the /API/v1/schools. And also we can search by trace ID, and here we have all the information that we need. For example, we have these tags, we have the URL and the method, what was the outcome, and so on and so forth. So also if we, for example, insert some students and then we perform a get request and go back to Zipkin, and here we do find query, we see that we have all the tracings right here. So here we see that we have 2 for gateway, 1 for school, and so on and so forth. So now all the logs and all the traces are centralized into Zipkin.